we would like to introduce the concept of a complex number. Now, we'll write complex numbers in the following way. We'll write a complex number z is equal to what we call the real part plus the number I times the imaginary part, where I is defined to be the positive square root of the number -1. And this representation of a complex number as a pair of real numbers given by this sum is our definition of a complex number. Now, we call the real part of the complex number x, and the imaginary part of the complex number z, that's referred to as y. So we have the real part and the imaginary part. So we'd like to represent a complex number in the plane where we have x and y, and our complex number z is given as x plus iy. Now, we'll draw an angle theta in the complex plane, and the length of this line here is we're going to refer to as the modulus of z. Now, when we have x and y in here, you can see that the length of that line should be x squared plus y squared to the 1/2. And then we can write our value x as the length times cosine theta, and y as the length times sine of theta. Now, there's a more formal definition of the modulus that goes like this. Let's define what we call the conjugate complex number z as equal to x, and we write it as minus iy. So when we take the product of the complex number and its conjugate, that's x minus iy plus times x minus iy, and we multiply these terms out, we get x squared. Now the cross terms iyx and minus iyx vanishes, plus y squared, and we define the modulus of the complex number then to be z bar to the square root, which is equal to x squared plus y squared to the 1/2. So that motivates our representation of the complex number. Let's just, on the same picture, if we have a complex number z, then we have its imaginary part. So this is our x, and this is our y. And if we want the conjugate complex number, then all we're doing, here we have z is x plus iy, and the conjugate z bar is equal to x minus iy. So we're just having a negative imaginary part. This would be an angle theta, and this makes the same angle theta in that plane of representing the complex number. So this is our first start on representing complex numbers.